All right, Algebra 1. Welcome back, guys. We are in Section 2 today. Chapter 9, Section 2, all about multiplying polynomials. All right, so some of this stuff you actually do know already because you did this in Chapter 8. Okay, so some things to not forget, as it says here, don't forget, when you are adding the exponents, or actually, sorry, don't forget to add the exponents when you're multiplying with numbers that have the same base or a variable that is the same base. Okay, so this goes back to Chapter 8 stuff. When you're multiplying, you got the same base. What do you do with those exponents? You add those exponents. Okay, and so you are using a lot of the distributive property. And you actually, again, have already done a lot of these concepts back in Chapter 8. So for some of you, you'll remember it. This is going to be good. For those that don't really remember it, that's okay. But it's going to help you a lot to keep building on all of your past knowledge. All right. So this is one way to think of the distributive property. It's called FOIL. And you'll see I kind of put a bold letter for the first part of each word. That's how we get FOIL. It stands for first, outer, inner, last. All right, and you're going to see what that looks like when you are taking a binomial and you are multiplying it by another binomial. Okay, so you're going to see what that looks like. But if it doesn't make sense, this whole thing of saying FOIL, it's just a double distributive property. That's all it is. Okay, so maybe that makes a little bit more sense to think of it like that. So let's get into it. Let's see some example problems. Let's walk through this together. Just 4 example problems, all right? That's all we need. All right, here we go. So what we have is we have 2 numbers, 5 and 3. Both are coefficients, and this is being multiplied together. Okay, so the 5 and the 3, they can easily be multiplied together to create 15. Now, here comes the part where it's the same base, add the exponent. All right, I'm going to put a 1 right here because we have to know we're looking at the same base. They're both x. So what do I do with those exponents? I have a 3 plus a 1 giving me x to the power of 4. Okay, so if you want to really expand this out and see what we did 5 times 3 times x to the third times x to the first. All right, this is what gave me 15, the 5 and 3. This is what gave me x to the fourth. And then you just put those together. Okay? All right, number 2, distributive property. We are using it throughout the entire section. Okay? But what is not written is there's a coefficient of a 1. All right, because you may wonder, all right, what does the 7 have to go with? It doesn't really have anything to go with. So it's kind of like the 7 and the 1. All right, but then you have the same base. There's an x, there's an x, and again, they don't write it, but there's always a 1 exponent going right there. So 7 multiplied by 1 gives me 7. All right, 7 times 1 giving me 7. Then I have x squared multiplied by x to the power of 1, same base, add the exponents. So x squared times x to the power of 1, it's going to give me x to the power of 3. And then we have this final piece where you have a 4 multiplied by an x, which will simply be plus 4x. Now, what I really want you to make sure you grasp here is that these are not like terms. They both have x, but they both do not have the same exponent. So I cannot go any further in this problem. I cannot put 7 and 4 together because they don't have like terms. X to the power of 3 with x cannot be combined. So then this one is done right there. That's it. Okay. All right. Now comes the double distributive property. All right. So 4x is going to go here, and it's going to go here. All right, so let's do that first before we proceed. So 4x multiplied by x, let's see if we can start to figure this out a little bit quicker here. It's going to be 4x squared. Okay, then we're going to have -1 multiplied by x and -1 multiplied by 5. -1 times, oh, and I'm sorry, I just skipped a step. 4x times 5. I jumped ahead, didn't I? In fact, let's just go backwards a bit. So 4x still needs to be multiplied by 5, giving us a positive 20x. Now we can proceed. -1 times x gives us -1x. And -1 times 5 gives us -5. Now let's look for like terms, because I do have them. 20x and -1x. These guys are like terms because they both just have x. All right, so 4x squared plus 19x minus 5. Now I can't go any further because none of what is left is a like term. I have an x squared, I have an x, I have a constant. None of them are like terms anymore, so that's the final answer. All right, let's do another one, but now we're going to see a little bit bigger. We have a full trinomial right here, and then a binomial right here. Okay? It doesn't matter which direction you go. Now, what do I mean by that? I mean, do I take these terms and multiply them over here? You can. Not a problem. You're going to see a lot of arrows there. You could do that. You can go the other direction too. So you could take 2x and go here, here, and here. Then you could take -3 and go here, here, and here. You could do that. So I'm going to show you that direction just so you can see either direction. It doesn't matter. You just need to make sure that everything gets distributed to everything on the other side. All right, so let's do that. So 2x is going to go here, here, and here. All right, so 2x multiplied by 3x squared. 2 times 3 is going to give me 6. Then x and x squared is going to give me x to the power of 3. All right, now the next piece. 2 multiplied by the unwritten 1, by the way, -1, is going to be -2. Then x multiplied by x gives you x squared. Then 2 multiplied by 5 gives you +10. And then don't forget, the x gets dropped into the answer. That x is that x right there. Okay. Now we have to do the -3. So let's change the color. Let's show -3. It's going to go here, here, and here. All of that. So -3 times a +3 gives me a negative 9. But then the x squared right here is what gives me that right there. Okay, next part. Negative 3 times a negative 1. Don't forget, that's a negative 1 and a negative 3 would give me a positive 3. And then the x needs to get tagged onto that. There's the x, there's the x. Okay, now negative 3, positive 5, it's going to make a negative 15. Okay, let's find our like terms. So I see an x squared and I see another x squared. So these guys can go together. I see an x, I see another x, so these guys can go together. And it doesn't look like we have any other like terms. So let's combine what we can. The 6x to the power of 3 had nothing to go with. So that drops straight into our answer. Then I have a negative 2x squared. I have a negative 9x squared. They're like terms, both negatives. So that's going to be negative 11x squared. Then I have a positive 10x. I have a positive 3x. That's going to create a plus 13x. And then the negative 15 doesn't have anyone to go with, so it just drops straight into the answer. All right, and this is our answer. Notice again, like last section, it goes in that perfect descending order, meaning biggest exponent, in this case a 3, going all the way perfectly down to the constant value. So see how we go. 3, 2, there's a 1 there, and then there's a nothing. All right, do that every time with your answers. All right, guys, that's what we got. So let's zoom out. There's everything, all 4 example problems. That covers section 2. Diligent notes, write everything down. Watch all the videos, ask questions in class. There we go. I'll see you guys in the next one.